Hello, y'all. Welcome to Lesson 15, Structure 1.4.3 of my DP Chemistry curriculum. This is probably one of the most important sections within your entire chemistry curriculum, as using molar mass with the units grams per mole inverse. Using this one piece of information, this one tool, this one conversion factor is going to get you more marks on your DP tests than anything. This is something that you must be confident in using. Once again, this is probably the single most important concept in your DP chemistry curriculum. With that said, learning it and its usage is not too inherently difficult, but you need to be confident and you need to be able to know when to use it and how to use it. So, with that said, let's get going. So, we should be able to solve problems involving the relationships between the number of particles, the amount of substance in moles, and mass in grams. We have this nice little formula. Moles is equal to mass over molar mass, which is in the data booklet. But by the end of this, I hope you don't even need that. So with that said, let's start with a little bit of stuff you already know, some prior knowledge. So we have A sub R and M sub R, which are relative atomic mass and relative molecular mass, respectively. And something about these is these are unitless values. Furthermore, we also have moles, which is measured with the unit mole, and or we use the unit mole. And furthermore, this is a number, which means you don't necessarily need a unit for it, even though we do have a unit. It can be a unit, but you can also say 1 mole of something. Um, and the thing about that, because it's a number, we cannot weigh it, cannot make a scale or beaker that measures in moles, which sounds kind of wild, but if you take a minute to think about it, that makes sense. Your beakers measure in liters, your scales measure in grams, but you've never seen one that says moles, and you never will because mole is a number. If I have one one atom or one elephant, I mean, one elephant weighs a lot more, but I'm still measuring one of something. You have to remember a mole is a number. So a mole of atoms and a mole of elephants have two completely different weights, have two completely different volumes. So we can't really use mole as a tool of measurement within a lab. Now we want our numbers to be in moles and we want to use those because they're quantifiable values for things small, but we need a way to get there. So what I'm saying is we need a relationship between moles and mass or volume, as those are the quantities we can measure in a lab. These are measurable units. So enter molar mass. Molar mass, we generally refer to it with a big M, is simply the mass in grams of 1 mole of substance. Molar mass itself has the units of grams mole inverse. In other words, grams per mole. You'll notice the IB likes to put everything on the same line, but I think for clarity's sake, I like using division symbols and fractions even in my units. So grams mole inverse and grams per mole, same thing. All right. Now, the beauty of molar mass is that the numerical value for any substance is equal to its relative mass. What I mean is either its relative atomic mass or if it's compound, its relative molecular mass. So what does that really mean? Well, quite simply, if we take the example of, so I'll use IE, if we look at carbon, carbon has a relative atomic mass of 12.01 as seen in the periodic table. Remember that comes from the average mass of isotopes. Now, 12.01, you'll notice there are no units because relative atomic mass is a unitless value. If I were to get the molar mass of carbon, it would be equal to also 12.01 with the units grams per mole. What that means is if I had a beaker with exactly 6.02 times 10 to the 23rd atoms of carbon, so that's once again also 1 mole, and I were to put that on a scale, that scale would read 12.01 grams. So that is what molar mass says. Molar mass says that specifically the mass in grams of 1 mole of substance. So 1 mole of carbon has a mass of 12.01 grams. And that's how we measure things in a chemistry lab. So I think we should practice this just a little bit. We'll be doing a bunch of practice. So practice problem one. And remember, you can pause these and try them yourself. What is the molar mass of helium? So go ahead and figure that out. Otherwise, I'm going to get going right about now. Well, I know the relative atomic mass by looking at my periodic table says it's 4.00. Therefore, my molar mass is equal to 4.00 grams per mole. This is not a trick question. What I'm asking you to do is one, find helium on your periodic table, two, identify its relative atomic mass, and three, add that little unit, append grams per mole. Units are incredibly important in the study of chemistry as they allow us to do conversions and quantify our particles. So, practice number two, a little harder. What is the molar mass of chlorine, which chlorine is diatomic, meaning it comes in two chlorines bonded together. So you go ahead and solve it yourself, pause it, and then come back to the answer. Otherwise, I'm starting now. I know that the relative atomic mass of chlorine is actually 35.45. However, I have two chlorines. So the molecular mass, relative molecular mass of, or formula mass, sorry, of chlorine is going to be 70.90. All I did was multiply by 2 for the two chlorines. Therefore, the molar mass is going to be 70.90 grams mole inverse. Now I'm using grams mole inverse. I'll switch them up often just to get you used to the IB's way of doing things. All right. So we know how to do that. Congrats. You've done it. So what do we actually do with molar mass? Well, this allows us to convert from grams to moles and vice versa. So we can take grams of a substance and find out how many moles, or moles of a substance and find out how many grams, and we'll be using molar mass. Now, the units of molar mass is grams per mole. Therefore, you should know that the formula for molar mass is the mass over the number of moles. These are the symbols the IB uses. So this is mass in grams, and this is moles in moles. The actual formula that you have in your data booklet is usually given in a different way. It's usually given as the number of moles is equal to the mass divided by the molar mass. Now, you can use this formula for all these problems I'm about to do next. However, I do it a slightly different way because I'm going to take us into the idea of stoichiometry, which is how you start converting between different quantities and quantifying chemical reactions. So, with that said, let's continue our practice. So we'll do some practice. Whoops, can't spell. Practice continued. All right, so we're on number 3. So what is the mass of 3.00 mole of beryllium? So again, pause it, otherwise I'm getting started right now. All right, so I know my relative atomic mass of beryllium is 9.01 as given by my periodic table. Therefore, my molar mass is also 9.01 grams per mole. All right, so I'll start with my problem. I start with my given 3.00 mole beryllium. I know that I'm looking for mass in grams. So what I'm going to do is I'm actually going to grab some big parentheses that have a top and a bottom. And I know that I want to end up with grams, and I know I want to cancel out my moles because I do not want the unit mole. And using like algebraic techniques, if a unit's on the bottom and a unit's on the top, we'll be able to cancel these. So now I just need to plug something in these parentheses, something numerical that has a grams on the top and moles on the bottom. Well, if I look right here, molar mass has grams on the top and mole on the bottom. So I'm going to go ahead and plug in 9.01. And now I'm just multiplying by my molar mass. And when I multiply by my molar mass, my mole unit cancels out. I'm left with my gram unit, which is what I want. And I get an answer of 27.0 approximately. It is 27.03, but we'll talk about significant figures in another section, which tells us how many figures we have in our answer. But 27.0 grams of beryllium. So there is our answer. Number 4, we can go the other way as well. Moles of NaCl, whoops, that C looks lowercase cl, in 15.0 grams of NaCl. So how many moles are in 15.0 grams of NaCl? So once again, the first thing I'm going to do is find out that my relative formula mass of NaCl is going to be equal to sodium's, which is 22.99, plus chlorine's, which is 35.45, for a grand total of 58.44. And therefore, if that's my molecular mass, or sorry, my formula mass, my molar mass is 58.44 with the units grams per mole. I'll start my problem now with my given 15.0 grams NaCl. And I will do the same big parentheses, but this time I want to end up with moles. I want moles as my answer, so I want moles on top. And I want to cancel my grams, actually. I don't want these. I want them to go away, so I need to put grams on the bottom. So grams, mole. Now I need a unit that has mole on top and gram on bottom. And I look at my molar mass, which unfortunately that's gram on top, mole on bottom. But the beauty of this is I can actually just switch them as long as a number comes with it. So I notice that the number 58.4 is the grams, 0.44, and mole stays on top. So now what I'm doing is division. This is 1 mole over 58.44. I will cancel my units. I will have mole on top just the way I wanted it. And I will get a grand total of 0.257 moles NaCl. All right. So we can do it in both directions, mass to moles or moles to mass. Either way, it works. All right, the last thing that you need to be able to do. By the way, before I go any further, this right here, converting from mass to moles and moles to mass, this is it. This is where everything in chemistry, everything quantifiable in chemistry comes from. This is the number one skill you need to be able to do. So moving on. The last part is we can convert from moles to atoms, or sorry, not just atoms, moles to elementary particles. We did that before. We used Avogadro's constant. Avogadro's constant. But now, because we can also do mass to moles, we now have a way to convert mass all the way to elementary particles. Granted, we cannot go directly there. We have to use the mole to get there. So, and just to clarify, we are using molar mass here. So let's go ahead and continue our practice to number 5. How many molecules in 75.0 grams of CO2? So I'm going to do the thing that I've started with first every time. I will find my relative mass, m sub r. That's going to be 12.01 from carbon plus 16.00 from oxygen times 2 because we have two oxygens. So my mass is going to add up to 44.01. Therefore, my molar mass is going to be 44.01 grams per mole. All right. Now, I notice that I'm starting with a mass. So I'm going to go ahead and write my given 75.0 grams CO2. I do not want grams. I want molecules. So looking here, I first must convert my mass to a mole value. So I'm going to draw my big parentheses. And like I said, we want a mole value. So I will put mole on top. I'll put grams on the bottom so that they cancel out. And the same trick we did from number 4, I will use the molar mass, 44.01. That will remove my grams, giving me moles. Now, here's the beauty. I don't have to stop and do the math. I can just keep adding another parentheses. And now I need to get rid of this mole value because what I want are my elementary particles. In this case, these are molecules. So I want molecules on top. And I want mole on the bottom so that I can ensure that this mole and this mole cancel out. So I'm left with the unit I want, molecules. So now I need some way to convert between elementary particles and moles. Well, that's just Avogadro's constant, which tells me that 6.02 times 10 to the 23rd molecules is 1 mole. So this is the way we do this conversion. And then I just cross things out. The beauty of doing it this way is any value that's on the bottom is divided, any value that's on the top is multiplied. And because ones have no effect in multiplication or division, you can just kind of ignore them, get them out of the way, which means you can type this whole thing into your calculator simply by just doing 75.0 divided by 44.01 times 6.022 times 10 to the 23rd. The best part about this is because this 10 to the 23rd is part of scientific notation, I can actually just move that, bring it to the end, and that'll be part of my answer. So when I put this whole block into my calculator, I get 10.2 times 10 to the 23rd. And then I can take that one step further by moving that decimal over and adding 1 to my exponent, therefore giving me a final answer of 1.02 times 10 to the 24th molecules of CO2. All right. The biggest thing about this whole type of conversion, these problems, is that they take practice. It takes time to be confident with this. And I urge you that if you are not confident in doing any of these style of conversions, you need to do one thing above all else, and that is practice. So, with that said, go on to your favorite AI tool or just Google practice mole conversion problems. Generally, this is called mole conversions. And just look up as many practice mole conversion problems and do them. Once you start feeling confident, then you're done. Or maybe do 15 more after that. Anyways, have a great day.